Okay, thank you. So I'm a JAXA staff, so I'm an engineer for a JSON team. In this session, I'm going to talk to you about deployment service for CubeSat from ISS. Now I try to share my presentation, okay? Can you see my presentation now?
Yes.
Okay, thank you. Okay, so first of all, I introduce of JAXA, okay? Japan Aerospace Exploration Agency, JAXA, was born through the merger of three institutions, namely the Institute of Space Astronaut Science, ISS, the National Aerospace Laboratory of Japan, NAL, and the National Space Development Agency of Japan, NASA. It was designed as the core performance agency to support the Japanese government's overall aerospace development and utilization. JAXA, therefore, can conduct integrated operations from basic research and development to utilization. I'm showing the representative project here. We have some mission, for example, today, I would like to explain about one of our human space activity missions. It is a CubeSat deployment mission. International Space Station, we call ISS, is a huge manned construction located about 400 kilometers above the Earth, and it is circled around the Earth at the speed of 90 minutes per orbit. ISS project aim at improving science and technology to enhance life and industry on the ground. 15 countries are participating in the ISS project, including NASA, Russia, ISA, Canada, and Japan. Japan has completed a human space facility, the Japanese experiment module Kibo, and trained astronauts who will operate ISS Kibo at JAXA. Kibo has a pressurized module and exposed facility, so a variety of missions can be conducted both inside and outside Kibo. At the Kibo exposed facility, there are a lot of unique systems. It has an airlock that allows a payload to be moved from inside to outside the Kibo. Okay, and the small robotic arm, it's called a remote manipulator system. So many missions can be operated at the Kibo exposed facility. One of them is GEM, Small Satellite Orbital Deployer. It's called JSOD. JAXA deploys this unique system to deploy the satellite and inject the orbit from Kibo. This table shows a specification of JSOD. Satellite size is defined as a unit, and 1U is a cubic of 10 centimeter. Okay? 10 centimeter, yes. And the JSON can be released up to 6 satellites, and the 50-class satellite can also be released, even though 1U, 2U, and 3U size of satellite is limited in JCube program. The ISS is moving in the direction of the plus axis, and the satellite will be deployed 45 degrees backward for the direction, okay? In which the ISS is moving. Maximum deployment velocity is 1.7 meter per sec, and the speed changing depending on the mass of the satellite. For the development mechanism of JSOD, there's a big spring inside the JSOD case, and the separation mechanism set on the outside of the case. As the satellite is loaded, the big spring is compressing, and the satellite are kept in the case by the door. When the separation mechanism receives the command for release from the ground, the separation mechanism moves and the door is opened finally. The satellite in the case are pushed by the spring and deployed. There are two types of case that can carry satellites the size of CubeSat. In the JSON case, the satellite is set to the case on the ground, and the maximum size is 3U in a slot. While in the JSON-R case, the satellite is loaded into the launch case and transported to the ISS, where it's stored in the keyboard module. In the keyboard module, the satellite will be transferred to the deployment case by astronauts. So the JSON-R can be used repeatedly and can release max 6 satellites in a slot. In addition, all the not shown here, there are special cases for the Y6 size and the 50 kilogram class. The operation commands to move the robot arm and to deploy the satellite are sent from the ground. Flight control team and engineering team are in perfect condition and support the deployment from the ground. The size of the satellite is small, but the mission is made possible by many support members. Next, I show the requirement of JSON and safety review in ISS. Requirement of JSON must be satisfied in order to deploy your satellite using JSON. This requirement is GEM Payload Accommodation Handbook for 8. You can download this document from this URL. I would like applicant of JCube program to read this document. Next, I show safety review ISS. I show the proceed of safety review. Hazard the may loss of the ISS, the directly harm crew on indirectly harm crews by damaging safety related systems should be identified early in the design process. In the case of CubeSats safety review, phase 1 and phase 2 are merged and held after critical design. In the safety review of phase 1 and 2, user of satellite make report including understanding the target system, hazard, cause identification, risk assessment, elimination of hazard causes, and set control verification method. And safety review panel checks this report and reviews it. And after production and testing of satellite, safety review phase 3 is held. Verification of hazard control method and evaluation residual risk and checking in this review. After this review passed, satellite can be handed over. Next, into the achievement of JSON. JSON operation started in 2012, and this year marks the 12th year. JAXA have continued to provide development opportunities, so 86 satellites from 31 countries have been successfully deployed from the JSON. As you can look at the world map, okay? We are releasing satellites from all over the world, regardless of region also. 9 teams of satellites were selected by JCube program so far, and 2 satellites of 1 team, okay, have been successfully deployed last month. Okay. I introduced capacity building through JSON. JAXA has provided the opportunity of satellite deployment to various countries as a gateway for sharing the value of IS-Kibo for the purpose of enhancing satellite development of operation technology. JAXA launched a new comprehensive capacity building measure to provide education program and sustainable satellite deployment opportunities, which finally contribute goals SDGs, goal 4, 8, and 9. JCube program is provided by after my presentation, okay? KiboCube program is collaboration with UNISEC. KiboCube program can provide 1U size CubeSat deployment. And you can search KiboCube using Google and Yahoo. Finally, I introduce KiboCube Academy briefly. JAXA and UNISEC launched the KiboCube Academy and posted a series of online lectures on the UNISEC website in order to enhance opportunities for the educational aspects of the satellite development, its operation, the project management, and the system engineering. JAXA also provides technical consultation for potential applicants of Kibo Cube by the collaboration with UNISEC. You can find the webinars on the webinar section of the following website, okay? And now you can see 24 lectures which are used for development of CubeSat. This year, 3 new lectures will be added in this lecture. We are hoping to see many institutions apply for JCube program and explore their possibilities of space utilization. JAXA is looking for the supporting your challenges. Lastly, I would like to show the movie of JSOT introduction, okay? Just a moment. Can you see sound?
But there's no sound.
Just a moment. Sorry, now I'm sorry. Just a moment. I tried to set. Now okay?
Yes.
Okay.
JAXA's GEM, Small Satellite Orbital Deployer, JSOD. The Japanese experiment module, Kibo, on the ISS. This project is conducted by JAXA, utilizing Kibo's distinct function of having both an airlock and a robotic arm. JAXA has provided many opportunities to universities, space emerging nations, private companies to deploy satellites. A standard 1-unit microsatellite, CubeSat, is 10 centimeters square in size. JSOD can meet various needs by accommodating 1 unit to wide 6-unit CubeSats and up to a 50-kilogram sized microsat. It is possible to load up to 12 1-unit satellites at the same time. In addition, to meet increasing demand, JAXA has developed a new deployment case, JSOD-R. JSOD-R can be used repeatedly and can release up to 6-unit satellites in a slot. Satellites are deployed using a powerful spring attached on JSOD cases. Satellites are launched into low Earth orbit for approximately 1 year. Let's see how satellites are transported to space and launched into orbit. User satellites are handed over to JAXA and carefully installed in a case. The case is wrapped with cushioning material and stowed in the cargo transfer bag. Compared to conventional rocket-mounted launches, this method drastically mitigates launch vibration, which contributes to reducing satellite development cost. After the cargo transporter reaches the ISS, the crew receive the satellite cargo transfer bag and conduct JSOD setup on board Kibo. The JSOD case is installed on the airlock slide table. As for JSOD-R, astronauts will load the satellites in orbit. The case is transferred outboard using Kibo's airlock and robotic arm, a unique dual function possessed only by Kibo. The Kibo Mission Control Room on ground conducts this operation. Developers and participants gathered at the Tsukuba Space Center watch in anticipation as the robotic arm is set to the releasing point. command is sent from the ground. Release. Since 2012, JAXA has been providing deployment opportunities to universities, private companies, many domestic and foreign users who do not have the capacity to do so. In addition, JAXA is cooperating with the United Nations Office for Outer Space Affairs and University Space Engineering Consortium to enhance social and international contribution. The world is entering a next space age, and the number of JSOD users is steadily increasing. Creative user ideas can extend the possibilities and value of low Earth orbit utilization, and JAXA continuously supports the pursuit of new possibilities. Now, the next satellite deployment from Kibo could be yours. Good luck.
Okay, so my presentation is finished, okay?
Okay,
So-
Tito-san, thank you. Thank you for the nice video.